Okay, so our topics for today are the following. Okay, so what is 5G? The anatomy of a 5G cell site. So we'll break down the anatomy of 5G cell site. So this is a different approach on discussing 5G. So we'll do a different approach. So aside from the previous discussions on the 5G from the Asia Open Academy, so we have developed a different approach on discussing what is 5G so that we can tackle on a more general discussions. So what is the anatomy of 5G cell site? We'll discuss about the antenna systems, the frequency, how to properly select frequency for a 5G technology so that it could help you understand why specific frequencies are used in certain areas and why are certain frequencies are used in this type of areas, like for example, private network, or sometimes in rural area or in urban areas. And what are the different transmission modes that is connected using the frequency, and how to select different architectures for 5G, and different voice services that we look into for 5G, and the location. So is it a terrestrial site or a non-terrestrial site? Okay. And of course, privacy. Is it a public network or a non-public network 5G? And we'll have a summary and we'll have the post test. Okay. So those are the topics that we will discuss for today. Okay. So far, so good. Am I audible? Can you hear my voice? Can I get a thumbs up? Okay. All right. So let's start with the connectivity challenges. So we'll start with the problem. Okay. We start with the problem that we have encountered, especially during the pandemic. So we have felt this tremendous need for connectivity, right? So if you are in the rural area like this, okay, if you're in a rural area like this, you will feel the challenges now outlined of the connectivity challenges. So what are the different challenges? No? So lack of cellular coverage causes the following challenges. Limited access in the remote areas. So this hinders you or hinders the residents the ability to connect, that impacts their various activity, no, or daily lives, like social connectivity and connecting to different family members, right? And then social connectivity issues, and then emergency services accessibility. So if there's a distant or scattered buildings that imply no, yung sparsity of the essential services, so medyo mahirap tayong kumuha ng mga emergency support, especially in a rural area. Imagine there's a medical emergency that happened. How can you get immediate support? Okay, if there's no connectivity in that area. And of course, there's a technological isolation. So this disconnection not only limits the access to information and technology, but also hinders the educational and economic opportunities. Sabi nga, no, if for those areas without internet connection, there is poverty. No? So the um, development, economical development in that area is very low because of the technological isolation. Okay, so we want to connect these areas with different connectivity solutions. One of which, what we are discussing today, is through the use of cellular communication. Okay, so we'll start our discussion with the wireless telecommunication system. So we discussed this in the previous session or previous webinar series in radio access network. Okay, together with Engineer Nika last time. So let's just have a brief review of what are the compositions of wireless telecommunication systems. First is the user terminals. Okay, so this is also known as a user equipment for 3G and for 3G, 4G, and 5G. So these are the devices that are being used by users, and it has different names. So if you want to go on technical details, so if it's a 2G mobile phone, it's a mobile station. But if you're using a 3G, 4G, or a 5G system, we call it the user equipment. Okay. But typically, we call it a cell phone or a mobile phone. Okay. So this is a user terminal. Followed by this is the radio access network. Okay. So this is the one that is providing the wireless connectivity that is required for your mobile devices to be connected to the core network. So the radio access network is connecting the user terminals using the what we so called air interface. Okay, yeah, air interface. Now we are connecting it through air interface. Hold on, I'll just put the laser point. Okay, so this air interface is composed of radio frequency. Okay, so later on we'll talk about this radio frequency. Okay. Now the radio access network has different generations as well. So if you are using a 2G system, we call those equipment on site as base station or base transceiver station or BTS. Now, if it's a 3G, we call it the node B. For 4G, we call it the evolved node B. And for 5G, we call it the next generation node B or the G node B. Okay. So typically, minsan nagkatalo-talo, no? Is it a RAN or a cell site? No? RAN is the composition of different cell sites. Kaya tinawag na radio access network. It's a network, no, of radio access sites. Okay. Now the RAN is connected to the core network. Okay. Core network is responsible for managing the overall operation of the network, including routing traffic between different networks and providing advanced services such as voice calling, messaging, or data services. Okay, so we connect the radio access network to the core network in the following means. We can connect it wirelessly using microwave transmissions. We can use it we can use a fiber optic or copper for old networks, but most of the time we are connecting now with the fiber optic. And for remote places, special locations that has terrain challenges, very far from the urban areas or the outskirts or the outskirts of civilization, we connect it through satellite. Okay, through satellite backhaul. So these are the three means now of connecting it. So you can see, it's just as easy as 1, 2, and 3. Okay, so any wireless telecommunication system, even if it's 2G, 3G, 4G, or 5G, or even probably 6G, or Wi-Fi, you will have these three main components. You need to have the user terminal, the radio access network, and the core network. Now, if you're talking about different technology generation, for example, 2G, 3G, or 4G, each generation or each component must support each technology. For example, if you have an iPhone 11, okay, which is only capable of LTE, you cannot use it for 5G system, okay, because that is an iPhone 11. Meaning, the electronic circuits or the chipsets inside the iPhone 11 is not compatible with the system of a radio access network that is 5G capable. So for you to be able to use the 5G system or service, you need to upgrade your mobile phone. So how do I upgrade the mobile phone, sir? You need to buy a new mobile phone. Okay, so from iPhone 12, 13, 14, 15, and 16, so those are the mobile phones that are capable of 5G. Okay, so that's how it's being explained now. So you need to have a compatible system for each generation. Now, of course, for radio access network, if the operator is not upgrading for a 5G system, so you will still subscribers also will not have a 5G services. Okay, so if the radio access network is only using an LTE network, so the operator needs to upgrade it into a 5G system. And the same thing as well with the core network. If your core network is not supporting 5G, so you will not be able to use the 5G service. So the core network must also evolve together with the other network elements. Okay? So again, we have three main uses: the user terminals, the radio access network, and the core network. Okay? Okay, so the radio access network, we use this as to provide mobile coverage. Okay, so this is the radio access network. So in the case of the Philippines, we are building a lot of mobile or radio access network. in the country, no, to have a seamless coverage. Okay. So in our country, so we have a different, we build no different cell sites or radio access network. I don't know if you can see that I'm populating it with different types of cell sites here. Okay. Ayan. So we are building different or numerous or thousands of RAN elements, no, to create a seamless coverage and mobility. And it depends if the cell site or radio access network is 2G capable, 3G, 4G, or even 5G capable. Okay. Now let's move on to the evolution of mobile communication. Okay, so as we mentioned, the wireless technology is evolving. So from 1G, which is amps, TAX or NMT, started in 1980. It's a foundation of mobile technology. It's the first time that we can make calls um, outside of our home. No? You can carry your phone. So that's why it's called mobile phones. So you can carry it with you and then make calls anywhere as long as there is a cellular service. And then it evolves to 2G. So it's a digital version of the 1G phone. So the most famous technology is the GSM, the Global System for Mobile Communications. Okay, so GSM gave us voice call and SMS and other services as well. So when it reached here in the Philippines, they believe that the killer application would be voice, but in the case of the Philippines, it became as the SMS or the text messaging. So we have achieved around, during my time, 100 million SMS per day. And then that is equivalent to 100 million pesos per day. Because one SMS that time was equivalent to 1 peso. Okay, not unlike today, it's unlimited. Ginagamit pa nga ng mga scammer. Okay. So 2G. And then we move on to 3G. UMTS, so Universal Mobile Telecommunications Service. So it's a foundation of mobile broadband. Although in 2G, they introduce a data connectivity like the GPRS, which is around 56 kbps, and EDGE or enhanced data rate for GSM evolution, which we can have around 384 kbps maximum. But it's not enough, no, for us to have or enjoy the internet services. So that's why in 3G, it's a combination of mobile broadband. So this is where we have heard the data connectivity reach up to 1 Mbps or 2 Mbps. But it's a combination of voice and data. Okay? So that is the foundation of mobile broadband. And then year 2010, they have introduced a new technology, the 4G technology, which is LTE, a long-term evolution. No? Meaning 4G LTE is 4G is a long-term evolution. LTE is a long-term evolution, which is 4G, fourth generation. Okay, so it's a further enhanced mobile broadband. So it reached around 150 Mbps in the downlink and 75 Mbps in the uplink. And we have seen LTE has evolved, no, through time, no, from 2010 up to this date. There are LTE networks in different parts of the globe that reaches around 1 gigabit per second. So they call it 4G or LTE or gigabit LTE. No? So they have reached that kind of throughput in LTE because there's a lot of techniques like wider bandwidths and different antenna techniques or different antenna solutions like massive MIMO. Year 2020 is a new era for us in the telecom industry. So this is where the 5G has been introduced. It's a future of mobile communication. And I will not discuss more on this slide now. So because we have different or a lot of topics on the next slides. So this is the future of mobile communications for 5G. Aside from high data rate, it also introduced multiple connectivities and latency, ultra fast latency. Okay, so there's a diverse opportunities with 5G. So this is the mobile communication. Now I have an additional slide showing the different technologies. So for 1G, for 2G, for 3G, for 4G, and for 5G. And I also include here for 6G if you're wondering what's next no, after 5G. So it's 6G, but we're still looking at it probably by 2030. So we still have a lot of time studying 5G. So later na tong 6G, no? Okay. But if you can see, every 10 years, almost 10 years, there is an upgrade happening or some new technology that is being introduced in the industry. Okay, but in this webinar, we'll focus on 5G technology. So what is 5G? Okay, what is 5G technology? If you were asked in an interview, what is a 5G? So this is the simplest explanation and most effective way to answer what is 5G. So 5G is a fifth generation of mobile communications that uses new radio access called NR. So whenever you hear the word NR or new radio, we are talking about 5G. Okay? Is that clear? Can I get a thumbs up? If somebody tells you that LTE is 5G, it's not true. Okay? NR is LTE or NR is 4G, it's not true. So NR is a 5G or next generation network. It's a fifth generation and connected to a new core network, which is called 5GCN. Okay. And focuses on three distinctive classes of use cases. So what are those three distinctive classes of use cases? First is EMBB or Enhanced Mobile Broadband. Okay. Next is Massive Machine Type Communications or MMTC. And then the ultra reliable and low latency communications. Okay, so those are the three distinctive classes of use cases of 5G. So what are those in simple terms? Pag sinabi nating EMBB, no, when we talk about EMBB, that means high data rates and high traffic volume. So this is where you get 1 gigabit per second when you do a speed test. So that is EMBB. So that is an evolution of an LTE throughput. So for example, in LTE, if you can get 50 Mbps or 100 Mbps, it's a 5G, you will get higher than that. In some cases, we get 300 Mbps or 500 Mbps. We call it the EMBB, Enhanced Mobile Broadband. And then what is Massive Machine Type Communications or MMTC? In simple term, MMTC is a massive number of devices, low cost, low energy consumption, small devices. We call it also the massive IoT or the Internet of Things. Okay, so mas marami tayong pwedeng i-connect sa ating 5G network. So we call it the massive machine type communications or massive IoT. And last use case is the ultra reliable and low latency communications. So let's break it down. Ultra reliable. No? So hindi ito basta-basta nagda-down. So there's a lot of redundancy happening in the system. Okay? Low latency meaning instant response of the network as low as 1 millisecond. No? We are designing the network that is ultra fast, no, to support use cases or applications that will be able to support or critical to save a human life. Yeah. Okay. So URLC meaning very low latency and very high reliability and availability. Okay. Now, if you look at the one of the architecture of implementing 5G, so this the holy grail of implementing it. It's the option 2, the standalone deployment. So in the standalone deployment is a straightforward architecture. It's a plain 5G core network connected to a 5G NR or a G node B, and then you have a 5G UE capable of SA. And then you have the NGC, the control plane, and the user plane. Okay, so this is the standalone deployment. But later on, you will see different architecture for 5G. There's an option 2, option 3, option 4, option 5, and option 7. So what are the differences? We'll tackle that on the second part of this discussion. Okay. Okay, so far so good. Can I get a thumbs up? By the way, we have reached 2021 participants right now. So thank you for those participants. Okay, so let's have a poll if you really understand what we are talking about here. Okay, so I'll move to the next slide. Before we start this, I'll launch a poll. In 5G, what is the meaning of NR? Okay, so let's see this. Kakasabi lang natin yan. Okay. Okay. Is it new range, no radio, or new radio? Sabihin na iba na pindot lang, sir. Okay. Pindot lang po. Okay, so let's end the poll. Do you want to see the result? Yeah. May sumagot ng 13% is new range. 1% is no radio. And new radio is 86%. Okay, we hope na mag-improve yan. Okay. All right. So that's the poll. Okay, let's move on sa 5G performance targets. So what are the different targets of 5G? Okay, so we have the enhanced mobile broadband on top. On the sides, we have the ultra reliable, low latency communications, and the massive machine type communications. Now you will see here an octagon. It's an octagon. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, an octagon. No? Yeah. So you will see a regular octagon. So this is the target of the IMT 2020. Okay, so this is a project of the International Telecommunications Union for each technology. Now, IMT Advanced is for LTE. So you will see this irregular octagon inside. So this is the target of LTE when they develop the LTE technology. So if you will see the target, the target to, when we say target, it's not on the first day. The first day that you will reach this target. So it's a progress. It's a progressive approach of getting this target. So for LTE, during that time, the target was 1 gigabit per second. Yeah. So pero yung unang deployment of LTE, the first throughput that we have got was around 120 Mbps in the actual during the time of San Miguel Corporation. Okay, when I was in Ericsson, that was a target. And then you will see that there are different networks right now reaching 1 gigabit per second for LTE. Okay. Now for 5G, the peak data rate target is 20 gigabit per second. Okay, 20 gigabit per second. That is equivalent to almost equal 20,000 Mbps. Okay. For area or throughput whenever needed is 100 Mbps. Okay. Spectrum efficiency is 3 times of LTE. The speed is up to 500 kilometers per hour mobility. So just imagine you can have 5G services on an airplane or a fast-moving vehicle. The latency is 1 millisecond. And the connected devices is 1 million devices per square kilometer. In terms of energy efficiency, is 100 times compared to LTE, and the area traffic could be 10 Mbps per square meter. Yeah. Okay, so these are the performance target. Now, if you will look at IMT 2030, okay, IMT 2030 is the project of ITU for 6G naman. So IMT 2030 also have this kind of comparison with 5G. In some white papers, you will see a 1 terabit per second target for 5G. Okay, for 6G, sorry. So meaning the 5G network will provide 20 times the LTE capacity, 10 times user experience rate, and in the millisecond level air interface delay. Yeah. So if you want to go deeper, this is the reference, the ITU references, recommendation, and the 3GPP references. Okay, if you want to go into detail. Dito nyo makikita yan. Now let's move on sa use cases ng 5G. So enhanced mobile broadband, the ultra reliable and low latency communications, and the massive machine type communications. So if you look at the use cases, so there's a pyramid, a famous pyramid of use cases. And in these use cases, there is an overlapping of different applications where you can use 5G. For example, in EMBB, the most direct application is the gigabytes in seconds, where you can download data in gigabytes per second. Okay. You can also watch 3D video, ultra high definition screens, work and play in the cloud, augmented reality, and then going to ultra reliable and low latency communication leg, you will have this kind of industry automation, mission critical application, like for example, e-health and self-driving cars. Okay, so later on, pag-uusapan natin yan. And going to the left, sa massive machine type communications, you will have the smart city. So you can install different devices like CCTV, traffic lights, sensors in a smart city. No? Meron kang smart elevator, meron kang smart air conditioning unit. Okay, so you can put everything because the capacity of the 5G system. And then you also have some voice, no? Voice services. And then sa mga bahay, we have the smart home building. Okay? So we can see in different countries like US, so they are implementing the smart home. Sa Pilipinas, meron din naman, pero bihira. No? Bihira yung may smart home. Meron lang tayo, tinatawagan lang tayo ng ating mother to turn off the light. Manually, no? Manually. Okay? But probably it will happen that most of us will implement the smart home automation. Okay. Okay, so these are the 5G use cases. Okay. Now let's move one by one, no, sa different use cases. Like for example, here in the enhanced mobile broadband, EMBB. EMBB is the natural evolution to existing 4G networks that will provide better user experience than current mobile broadband services. So enhanced mobile broadband yan. Ano? So you will have seamless connectivity, high data rate scenarios, high density scenarios, higher user mobility, meron tayong mga fixed mobile convergence, and yung femtocell deployments. Femtocell deployments is something like a deployment in your house, kinakabit siya ng mga operator, but instead of a Wi-Fi access point, para kang merong mini cell site sa loob. So ang lumalabas doon is 5G, okay, not Wi-Fi. Okay. So the EMBB target is 20 gigabit per second sa downlink and 10 gigabit per second sa uplink, 50 Mbps everywhere. Meron kang mobile fixed wireless access, and then you have this virtual reality, yung kinakabit sa ano, nanonood ka, and then augmented reality, smartphones, and 4K and 8K UHD. So EMBB is the initial phase of 5G deployments. Ito yung unang-una nating ma-experience. Later on, makikita nyo kung bakit. Because of the implementation in terms of the architecture. So it has higher capacity, enhanced connectivity, and higher user mobility. Okay? So this is EMBB, Enhanced Mobile Broadband. Next is Massive Machine Type Communications, or MMTC. So si MMTC, sabi ko kanina, this where you find the Internet of Things, mga smart wearables, and sensor networks. Okay? So if you are a student planning to have a thesis, ayan, so marami tayong mga use cases using IoT devices. So the best way to formulate a study about the wireless telecommunications, yung mga frustrations dito sa Pilipinas. You can start with that. Number one frustration is traffic. So if you can propose a smart traffic light, no, powered by artificial intelligence na, so you will combine different technologies like 5G, artificial intelligence on a CCTV camera na nakalagay dun sa traffic light, no. So instead of a traffic enforcer na ang tagal magpag-go, or sometimes yung traffic light, if it's automated, sometimes hinihintay niya yung 120 seconds kahit na wala na nakapilang sasakyan, ano. But if it's operated or connected with 5G and operated with artificial intelligence, it will monitor, no, kung nagpa-pile up na yung pila ng sasakyan. Okay? And then it will decide by itself kung kinakailangan niya ng ipag-go. And then kung meron tayong nakikitang tumatawid, okay? And then ma-identify ng artificial intelligence, yung CCTV, yung camera, powered by artificial intelligence na talagang mabagal maglakad. No? For example, sa US, they have developed this kind of camera, traffic or CCTV camera na nag-identify if the person walking or crossing the street is an old person. And then kung merong kid, no? So it will automatically calculate how much time the old person needs, no, to cross yung kalsada, and then it will give additional timer. Unlike dito sa Pilipinas, alam mo nang matanda tumatawid, ano, kapag ka 5 seconds, 5 seconds dapat. Pagka inabot ka ng 5 seconds, it's up to you. Good luck na lang, no? Yeah, ganun, eh. So we need to devise a more intelligent network, especially here in the Philippines. And as a student or as a researcher, you can also propose something like that, no? Malaki matitipid natin doon. Just imagine how much time is wasted sa traffic. Okay, so if you are planning to have like that, and then you want to have some support, just contact us. No? We will help you develop that kind of solution. Okay. Okay, so MMTC, also called as IoT, it refers to the enormous number of IoT sensors and devices that will be communicating with each other. Okay. This is an evolution of IoT technologies that we have today. So sa LTE, we have this kind of MMTC, version of MMTC. Ang tawag natin is narrowband IoT or LTE-M. Yan. Yun yung combination yan. We can implement this for smart cities, logistics, tracking, smart industries, smart agriculture, and fleet management. So this is an efficient and low-cost communications with deep coverage. No? Kaya ang ginagamit natin dito in terms of implementation for a 5G system with MMTC capability are the low-frequency bands. Kasi most of the sensors are located nasa basement, nasa loob ng bahay, okay, nasa loob ng no? So we are using deep indoor coverage. So high density up to 1 million devices. Well, aside from areas like, for example, kung yung system mo is nasa loob, you can use different frequencies. But if you're using a macro, you can use a low frequency band. Okay? So 10 years battery lifetime. Okay, 10 years battery lifetime. Next is the URLLC, or the ultra reliable and low latency communications. Okay, so this is defined as a network for mission critical and real-time latency applications that require uninterrupted and reliable data exchange. Okay, so itong ginagamit natin for URLC, most of the time we are using it, especially if there is a stake, no, na masacrifice yung human life or safety. Na kapag ka nag-fail yung network, there is an accident that might happen. So there might be a life that is put in danger. So that's why it should be ultra reliable and low latency. It should respond immediately. Okay. So you will see the high reliability, very low latency, and you will hear about tactile internet. Okay, tactile internet. So we can search more about this. This is how the systems or the networks are responding, no? Tactile, how fast the network is responding. High accuracy positioning, and then for higher availability, meaning hindi ka lang nakaasa sa terrestrial network. If the terrestrial network goes down, there should be a backup on top. So that is where the satellite connectivity comes in. Okay? Dito na pumapasok si non-terrestrial network, NTN. So we'll discuss it later on. And then mission critical services. So ano yung mga applications niyan? So makita nyo naman, napaka-logical, no? Remote surgery. Just imagine, no? Inooperahan ka, you're in an operating room, so the doctor already, hiniwa ka ng doctor, and then suddenly yung system is naglag. Uy! Naglag, sorry. Teka, i-reconnect natin. Just imagine yourself, no? Ano nangyari sa'yo, no? So immersive gaming, traffic safety and control, especially sa V2X. Okay, so for the vehicle to everything. So kapag ka nag-brake ka, dapat instantly mag-send yun ng signal towards the other cars, no, for them to respond. Okay, so you have a more synchronous system, especially for autonomous car. Okay, so URLLC is targeting a niche market. So meaning it could be autonomous car, health or sa mga industry applications. Ultra low latency of less than 1 millisecond, highly resilient and reliable device-to-device communications. So those are the three use cases, no, ng 5G. And then the different applications, there's a lot of applications that you will see that will emerge once 5G becomes a fully matured network, especially here in the Philippines. Okay? So ano yung tatlong use cases? Let's see. So sir, lagi may exam agad. Sabi niya, kala ko pa may pre-test muna. Yeah, lagi may pa-pre, lagi may mga pop quiz. No? Okay, so ano yung mga 5G use cases? Let's see. So the EMBB, the MMTC, and the URLLC. The main reason why I keep on saying this, no, kasi sa mga previous experiences namin, particularly sa terahertz, yung mga previous students namin sa terahertz, they gave me a feedback na ito yung kadalasan tinatanong sa interview, sa technical interview. Kapag ka nasagot mo yung tatlong yan, na-define mo yung 5G during the interview, medyo maganda yung position mo sa interview. So that's why I keep on reminding everybody ano yung 5G and then what are the different use cases. Okay? So let me share you the result. So EMBB, MMTC, and URLC. EMMA is not a use case. No? Ano yan eh? Suntukan yan. MMA yan. Hindi yan kasama. Okay? Ayan. Okay, so those are the different applications ng 5G. Ayan. So, what's the status of 5G network ba? Worldwide, sir, no? Ano bang status ng 5G worldwide? So, if you look at the commercial launch, 5G networks launch worldwide. So, this is based on the GSA, no? 5G market snapshot as of September 2024. Bago lang to. So, there are, by the end of July 2024, sabi niyo dito, so GSA had identified 622 operators in 185 countries and territories na nag-invest sa 5G. So, that includes trials, acquisitions of license, planning, network deployment, and launches. So, this number excludes yung mga nearly 200 additional companies, no, na na-award sa US na meron silang what you call this, auction do sa CBRS spectrum. Si US kasi is meron siyang Citizens Broadband Radio Service. Yung 3.5 gigahertz na frequency nila, they have allocated it for CBRS spectrum. Pwedeng gumamit yung mga private networks na gamitin yung frequency, no, kapag available. So they call it the CBRS. Kaya dumadami yung mga 5G mini operator doon, lalo na yung mga private networks. Okay? So maraming operators, no, ang gumagamit, no, ng 5G na, no. Now in terms of investing, so operators investing in 5G and operating commercial networks. So although marami nang nag-launch, marami pa ring nag-i-invest. Ibig sabihin, there's still an opportunity for us, especially for those radio network design planner, optimization. So there are still opportunities for us to get more contracts. Ayan ang titingnan natin dyan, okay? So if you would like to see this on a map, so the 5G footprint, so this is based on July 2024, okay? So these are the map of operator investments in 5G. So end of July 2024, so you will see marami na yung mga naka-deploy, especially sa US, but there are still areas planning, evaluating, testing, and trialing. Okay? So these are the areas, no, na sa iba't ibang parts ng mundo, no. You can see sa Asia, meron tayo sa what is this? Is it Papua New Guinea? Myanmar, And then itong mga areas na nakalimutan anong areas yan. Okay? So may mga ano pa rin, no? May mga areas pa rin, no? That starts to look or plan to deploy 5G. So what's in it for you, no? So ang maganda dyan, 5G is a global standard. So once you study 5G even here in the Philippines, when you go to US, Japan, Korea, South Korea, or North Korea, kung mag-deploy sila, Australia, the same 5G network or system that we study here in the Philippines is the same as the 5G that they will deploy no, in abroad or in other countries. I'm not saying that you go abroad, but I'm saying that there's still a lot of opportunities for 5G, especially for engineers like you. Okay? Okay. So yun yung ating mga status ng 5G. So how do we initially deploy a 5G? So let me share you an insight. No? It's an insight. Ibig sabihin, it's a macro way of initial deployment or strategizing deployment of 5G. Paano ba tayo, pag tinanong ka sa interview, how do you deploy or strategize in deploying of 5G network? So this is an initial strategy, no? So it could differ from different operator, different country, but at least you will have an idea. Paano ba nagde-decide? Ano yung mga considerations in deploying a 5G network? So when deploying a 5G, it's crucial to carefully consider yung mga factors. Yan. Ano yung mga factors? Such as spectrum, yung frequency selection, architecture, ano yung antenna configuration or the MIMO configuration, equipment, deployment strategy, attention to detail, yan is essential to ensure a successful rollout. First is spectrum. Meron ka bang frequency? Okay? Meron bang frequency ang operator to deploy a 5G network? Unlike here sa Pilipinas, maraming frequency ang mga operators. But in some cases, in some operators that I have seen in different countries, like for example, in one country in Southeast Asia, meron silang problem sa spectrum. Wala silang frequency na na-award pa. No? So you can choose 2.3 gigahertz, 2.6, 3.5, or the sub 3 gigahertz, 700 or 2100 megahertz. So if you deploy in these frequencies, you will deploy a FDD. And if you deploy here, you will definitely deploy a TDD network. So it's a crucial decision for operators to choose which frequency they will go or they will use in the deployment of their 5G. And one of the most critical part is, do they own this kind of frequencies? Or do they get the in the future no yung license to operate on those frequencies? Especially sa mga matured networks na meron na mga technology in this frequency na they want to reuse the frequency for 5G, but it's difficult for them. So that's why it's a critical decision for them. What frequency are they going to use to deploy 5G? So that's number one, frequency. For example, we choose 2.6. Okay, for example. And then how do we use this? Is it sharing or independent? So meaning if it's dynamic spectrum sharing, if you have the 2.6 gigahertz right now, if you're using it for LTE in your current network, do you want to do dynamic spectrum sharing? Dynamic spectrum sharing is meron kang frequency, you can use LTE sa kabila, and then sa baba is 5G. Or sa kaliwa is LTE, sa kabila is 5G. That is dynamic spectrum sharing. Or you can use it as an independent technology using the frequency. Meaning the 2.6 is solely for 5G. That's it. Okay? There's no other technology sharing the same frequency. So you will decide. Operators still need to decide if the frequency that you have chosen for 5G could be a dynamic spectrum sharing or independent. Okay? Next, after that is you will decide what kind of architecture are you implementing. Is it a non-standalone mode or a standalone mode? For most operator, especially like here in the Philippines, they go to the non-standalone mode first because they want to capitalize the LTE network. So the non-standalone mode, mamaya pag-usapan natin what is non-standalone mode and standalone mode. Then after that, if you decide, for example, a non-standalone mode, what type of MIMO configuration are you using? Are you using 88R, 8 transmit, 8 receive, or 32T, 32R, or 64T, 64R? So later, pag-usapan natin ano yung pagkakaiba niya, sir. MIMO configuration. So in some cases, like for example, in Thailand, they have chosen 64T, 64R immediately. No? And then 88R agad sa mga rural areas. For urban areas, 88R, and then in some areas is 88R. Okay? And then after that is equipment selection. So yung mga equipment mo ba for a current network is capable for 5G na. If not, you need to buy a new equipment. You need to invest on new equipment. So do you need to buy a new equipment? And then what is that equipment? Configuration. Is it capable of what kind of configuration? Okay. So this needs a very critical decision, no? For operators. And of course, why are you using it? Or why are you going for 5G? Bakit kailangan kang pumunta sa isang 5G network? Diba? Is it cool? Eh, hindi. Cool kasi. No? Trip ko lang eh. So in some cases, operators have three reasons. Number one is branding. If the network has, if they say that the 5G, if the network is capable of 5G, kahit isang site lang, it's good for branding. Meaning they are always on the lead. No? Sila yung leader. And you will see that no in their marketing materials. Number one telecom operator here in the country. So we are the first. Yeah. We are the first 5G network here in this country. Yeah. So lahat ginagamit nila yan. So is it for branding purposes only? Okay, because whenever you say first, it's not necessarily mean covered mo yung buong country. No. Probably first because you're the first one who built and transmit a 5G signal, no? Nakapag-test ka ng 5G. So it's good for your branding. Okay? So is it for branding purposes only? Number two, is it for traffic? Traffic augmentation. Meaning, there are certain LTE sites na hindi mo na kayang ma-upgrade. Kasi kahit ilang naglagay ka na ng additional frequency, naglagay ka na ng additional naglagay ka na ng different sectorization or antenna techniques like nag-massive MIMO ka na, okay, nag-ilang massive MIMO ka na, talagang congested yung site. And then the only thing that you need to do is to upgrade the technology to cater the traffic congestion, no? Para ma-solve yung traffic congestion na yan. So what they do is that they identify those areas, those particular sites na mataas ang traffic. And then that's the time that they will deploy. Okay, we'll deploy 5G here. Okay, so that's one. And of course, innovation. Yeah. So innovation is you really want to upgrade, no, yung user's experience mo. And then you want to also inject new use cases katulad na nabanggit natin kanina. So EMBB, URLC, or MMTC. Okay, so it depends on these three main reasons, no? Is it for branding, for traffic, or for innovation? Okay. Okay. So how do we deploy, no, a 5G system? So I'll have 2 slides, no, remaining, and then we'll have a quick break, mga probably 10-minute break, no, and then we'll discuss even more deeper, even more deeper. So sa 5G implementation, like what we have discussed in the radio access network, so meron tayong tower structure. So we have a tower structure. So the tower structure is the one that holds all the equipment. So it depends kung gaano kadaming equipment, how many equipment do you want to install on that tower. So ang nagde-decide niyan, the one that deciding which tower structure is the civil engineers. Okay? So when we say in a video na, for example, ang mga RF engineers ang nagpapatayo ng mga cell sites, no? Not necessarily mean kami yung nag-build talaga dyan, no? When we say nagpapatayo, kapag sinabi mo nagpapatayo ng bahay, we're not the one hands-on na naghuhukay, hindi. So you're getting the help of somebody. Okay? So ang nagtatayo are the civil engineers. Okay? So these are the tower structures. So para i-support yung ating mga equipment. And then you have your existing radio units, the RRU, if it's 900 megahertz. And then you have the 1800 megahertz. This is a typical example lang. And then you have your legacy antennas for low bands and for high bands. Okay? So these are the existing towers now. Then you have the jumper cables connected to the RRU. And then the RRU is connected to the CPR. The RRU is connected to the baseband unit using the CPRI, or the Common Public Radio Interface. This is a fiber optic going to the baseband unit that is capable of GSM, UMTS, and LTE. Okay? So from radio, jumper cable or copper. Okay? From radio to baseband unit, it's fiber. Okay? CPRI. And then the baseband unit is enclosed in an outdoor cabinet, or kaya nasa isang cabin yan, yung mga container van, which is nandun yung ating air conditioning unit or ventilation, kung may fan lang, power unit or DC, or backup battery, and then you have the transmission. Kung may fiber dyan, microwave, indoor unit, nandyan din. Okay? And then in some cases, dun sa mga tower companies, they also installing the monitoring and alarm systems. Kapag bukas yung pinto, kapag ka nagbabaha, o kapag ka may intruder sa site, so they're also putting this kind of monitoring system. So mga IoT devices yan. Okay? So nandito yung microwave antennas. Kung naka-microwave antennas, if you see a cell site na walang microwave antenna, that means connected yon ng fiber. Okay, naka-fiber optic siya. So you don't need this microwave antenna papunta sa core network. Okay? So how do we deploy a 5G? So if this is your existing typical, for example, you are an existing operator na meron ka ng existing na, for example, 2G, 3G, and LTE, and then you want to upgrade to 5G, usually they are putting this kind of equipment, the 5G active antenna unit. Okay? So meron silang 5G active antenna unit. So meaning this one is a form factor of a radio and antenna in one. So just imagine this equipment. These are the massive MIMO antenna. You know? So imagine itong dalawang to, the antenna and the radio unit are combined into one form factor. And that is called the 5G massive MIMO antenna. And then this massive MIMO, ito yung tinatawag natin 32T, 32R, or 64T, 64R. So meaning this has 64 transmitters, no, inside. No, ganun ang ano niya. No? Kung 32R. Okay? So ito yung active antenna. And then once you install the active antenna, you will, if the baseband unit is not capable of 5G, you need to have additional baseband unit. You need to purchase additional baseband unit. That's why it's very critical, no, for operators to invest on a 5G because it needs additional investment. So meron kang connectivity, baseband unit, direct na yan. Directly connected na yan sa ating massive MIMO antennas. So we call it the Enhanced Common Public Radio Interface, or the EC3. Okay? So the EC3 will be used to support the 5G by enabling yung increased efficiency. Yan. Okay? So ito yung ating 5G, and then may makikita kayo sa taas na bagong element. This is what we call the GPS for synchronization. Especially if you are using a TDD, a time division duplex system, which needs careful or critical synchronization. Okay, kinakailangan synchronization. If not sync sa ibang site, it will cause interference because you are using only one frequency in the downlink and uplink. Okay, so you need the GPS to do the synchronization. Okay, so kaya meron kayo nakitang GPS. Those are the TDD sites. Now, if you look at this one, is the actual implementation. So I just took a sample. So you will see ito yung legacy antenna, and then you will see a massive MIMO antenna here. Okay. Yeah. And then for some sites, I know you are familiar with the sites. So meron kang antenna ng LTE, and then you have a massive MIMO. So ito yung active antenna unit na yan. Okay? So those are the sample of 5G implementations. Okay, so if you see that kind, so there's a possibility na ito ay 5G. But in some cases kasi there are operators that they are not yet firing up yung 5G, naka-ready pa lang. So some of them, they are using it for LTE massive MIMO. Okay, but it could be a good indicator na kapag nakita mo, naka 5G phone ka, you see a 5G signal, nakakita ka ng cell site na ganyan, so you can safely assume na that site is a 5G capable site. Okay. So, next pag-usapan natin is ano-ano yung mga different factors no to consider. Ano yung mga different na pag-usapan natin in a 5G network system like this. So, on the next half, we'll talk about the antenna system, the frequency, the transmission mode, the architecture, the voice services, the location, and the privacy. Okay? Okay, now let's go to our 5G implementations and factors. Okay, so we have defined 5G, what is 5G, we have seen the evolution of radio access network from 1G, 2G to 5G, and then define 5G, what are the use cases of 5G, and then how do we deploy 5G, and then what is a typical implementation for 5G networks such as this. Now we will delve deeper on what are the different components or factors that we need to check. So we'll start with the antenna system. So is it a massive MIMO or a MIMO which 8x8 MIMO or a 4x4 MIMO? Okay, so what is it now? But before we go there, let's discuss about the area throughput definition. So how do we define the area throughput definition? Ano ba to? So the area throughput definition is the area throughput of a cellular network that is measured in bits per second per square kilometer. Okay, so that's how you dimension as well. No? How many people are there, and then what could be the throughput in per square kilometer. Okay, so it is illustrated in such a way that it is something like a volume of a prism like this. So the volume would be the area of the throughput, the area throughput, and then you have the average cell density, how many cells or cell sites are present in the area. Okay, and what is a spectral efficiency? So a spectral efficiency is how efficient you use the spectrum. It's like the kalsada or the road, how efficient the vehicles are using it. Are they congested? No, are they over-dimensioned? Yeah, so that is spectral efficiency. And of course, the bandwidth. How wide is your spectrum? Okay, so the formula is very simple. It's a multiplication only. Area throughput multiplied by the bandwidth, by the cell density, and the spectral efficiency. So you will get the area throughput, such as volume. Okay, so as mentioned, the bandwidth is measured in hertz. The D is the cells per square kilometer. And the spectral efficiency is the spectral efficiency of a cell. Okay, so this came from the Shannon formula. Okay, Shannon formula. So the Shannon formula actually is the capacity is equals to B, no, B multiplied by 1 plus Sn to the log of base 2. Now we will have another parameter here, which is N. Okay, N is the number of channel. Okay, that is where massive MIMO will come. Okay, so C is the cell dense network, B is the bandwidth, S is the signal to noise ratio, signal, and then N is noise. Okay, imagine if, for example, meron kang one cell and another cell. Okay, one cell and another cell, and then you combine it or overlap it. So there is what we call the interference. Okay, so if two frequencies, same frequency, overlap with each other, and then there's a receiver there, it will cause an interference. Okay, if the interference happen, there is degradation of quality, signal quality. It's nothing, nothing difference with the two persons talking at the same time. Cannot understand clearly kapag nasa gitna ka. Okay, so that's happened if two signals with the same frequency overlap on a receiver. So it causes signal degradation or quality. And then if the signal is degraded, so the spectral efficiency is affected. Okay, meaning you cannot transmit a lot of information because of the signal degradation. Okay, so this is what is being said here. Okay, signal to noise ratio. Now, if you have bigger bandwidth, malaki yung bandwidth mo. For example, 10 megahertz, 20 megahertz, or 60 megahertz. So you will have more data to be transmitted. And if you have a number of channels, marami kang channels, no, you can transmit multiple streams of data into one area without overlapping too much. No, it will improve your data throughput. So yun yung ibig sabihin, no? Okay? So, ano yung massive MIMO, no? So this is illustration. So this is coming from one of the experts in Ericsson, Emil. He's based in Sweden. So I got this from his YouTube channel. So if you are using a single antenna or antenna that has few antenna elements, so once you propagate it, kapag ka nag-propagate yan, it is distributing or propagating the power in all area. Okay, it's not very efficient because even though the user is here, you are also transmitting power elsewhere. No, so you are not very efficient in the use of your power. Okay, so just imagine if for example this one, no. Yes. So if there is a one user here, okay, so you can see that the signal transmission is being transmitted as well in some area which is wala namang subscriber. There are no subscribers here. Why are you transmitting power there? So it's a waste of power. Okay, it's a waste of power. So that's what massive MIMO is also addressing. You want to focus the power, no? You want to focus the power in such a location that you can concentrate the power so that also you can also increase the quality of the signal. Okay, so if you add more antenna elements, so there's a possibility that you will focus your antenna beam in that location. Okay, so ito meron na itong mga additional antennas or elements, and then another element, dinamihin nyo yung element, so you can see that the beam of your antenna is now more focused on that location. So you can focus the power and then increase also the quality. Okay? So ito yung different MIMO. So how that principle can be understood correctly, no? Or clearly. So I'll show you a simulation. Okay, so let me share the simulation. I'll share you the link also. I'll share you the link so that you can use it and then practice, no? And then if you're a teacher or a professor that want to demonstrate also the interference effect, no? Of the antenna or what's happening in the antenna, you can use this simulator. Okay? So here in the Asia Open Academy, we can share a lot of information sa inyo. We're not gating yung information. If that information could help you teach more students, understand the technology or the concept, we will share it with you. Okay, so imagine meron kang isang antenna. Okay? The antenna is creating, no? You are creating, you're creating waves, no? You are transmitting electromagnetic energy. So ito yung electromagnetic energy disturbance, no? Now, if you look at this, kapag nagkaroon tayo ng patak ng tubig, okay? So this is what happens, no? Pagka pumapatak, meron kang disturbance na nangyayari, no? So this disturbance is a change, no, in electric charge, okay, and then consequently have an electromagnetic change as well, no? So kasi kapag they co-create each other. So what happened is that, for example, this one antenna element. Okay, so we have one antenna element, and then magdadagdag ako ng additional antenna element. So look what happens, no? Kapag nagdagdag ako ng isang antenna element. Bubuksan natin itong isang antenna element, you will see what will happen. Anong nangyayari? Okay, I will open yung ano, no? I will open the chat box so you can comment. What's happening? What did you observe? Nag-ripple, nag-signal interference, they cancel out. Not entirely, right? Not entirely, but in some cases. No? So pag tinignan niyo yan, although ito, nag-ano siya, no? Gamitin natin itong ano natin. So when you look at, this area, yan. When you look at this area, you will see, tumaas yung signal level dito. No? The signal level has added, no? Nag-add up yung dalawang peak nitong signal na to. Because if you look at here, yan, nag-add up siya, no? Pero if you look at this point, nagiging low yung power mo. So ibig sabihin, nag-cancel out siya. Ibig sabihin yun, kapag yung dalawang signal na out of sync, pag nagbangga sila, nagka-cancel out sila. So this principle is used in massive MIMO, especially in the technology we call beamforming. Okay? So by adding multiple antenna elements, what happens is that you can control yung pinaka-beam ng iyong antenna. Okay, you can focus the beam of your antenna in a certain location. Imagine, dalawa pa lang yan. No? We are only using 2 antenna elements. Imagine if it's 3, 4, or 100 plus antenna elements. So you will have the capability to steer the beam, no, nung iyong antenna. And if you are using a Starlink dish, it uses a beamforming technology as well. Kaya nakagano lang siya. Pero ang nangyayari, it's changing the beam kung nasaan yung satellite, pagdaan ng satellite. Okay? So the principle is same like this. Okay? So you can use this simulation if you're teaching your students, especially in the RF technology, radio, electromagnetic spectrum, waves. You can use these simulations to strengthen, no, or to reinforce yung concept ng electromagnetic energy. Okay? Yan. So I hope na ganyan, i-practice niyo siya. So it's a good way to use simulators. Doon sa link na binigay ko sa inyo, maraming simulators doon. You can use the simulators, especially if you're learning about physics, na may hirap maintindihan, so you can use those simulators. And those simulators are free. If you want to just have a donation, pwede. But if you don't want, it's absolutely free. Okay? So, ano yung massive MIMO? So, we have seen the effect of multiple antennas, no, dun sa isang system. So, massive MIMO means multiple input, multiple output. It's the use of different or multiple streams of transmissions. So, ibig sabihin, you will transmit not only one stream, but multiple streams using different antennas. Okay, so if you are using multiple, we call it MIMO, multiple input, multiple output. SIMO is something like this, single input, multiple output. MISO, minsan kinakain natin to, but MISO is multiple input, single output. And SISO, single input, single output. So in terms of implementation, there's a different implementation. So meron tayong mga transmission diversity, but we will just focus on the MIMO first. Multiple transmissions of data. Okay? So in the MIMO type, we have 4x4 MIMO, 4x2 MIMO, 8x8 MIMO, and 2x4 MIMO. Okay? So anong benefits ng MIMO? So MIMO is, una is diversity gain. So it reduces the impact of fading when the signal fades on each propagation path are uncorrelated. So at least meron kang diversity gain, no? Kapag ka medyo pangit yung nare-receive mo sa isa, you still have another stream. Okay? Next is array gain. Okay, so this is achieved from beamforming effect, which is generated when transmitting from multiple antennas. So once you are using multiple antenna elements, so nagkakaroon ka ng something we call the array gain. No? Mas tumataas yung signal mo katulad na nakita natin. Nagpipick, no? Nag-add up yung peak signal natin. And of course, meron kang tinatawag na spatial multiplexing gain. It increase yung throughput by transferring multiple streams of data in parallel. So instead of sharing, no, sharing yung resources from one transmitter, so if you are separated physically, no, we call it the spatial multiplexing gain. So you can have your own resource. Yeah. So although may drawbacks ang MIMO, hindi lang siya for benefits, no. So of course it requires additional processing at both the transmitter and the receiver. It requires additional signaling, requires additional power, additional antenna elements, no, and medyo mahal, no, in terms of cost yung MIMO, no? Yeah. Okay. Yeah. So when you look at the laman ng MIMO, it looks something like this. Yeah, ito yung massive MIMO na antenna. So this is a typical Nokia massive MIMO antenna. So makita niyo marami siyang antenna elements here. Okay? So marami siyang antenna elements. Katulad ng nakita natin kanina, dalawang antenna elements lang yun. Yun na-simulate natin. So anong ibig sabihin nun? No? Anong ibig sabihin nun? So meaning is when you look at the massive MIMO antenna size, so these are the antenna elements. So imagine these are the faucets na kanina nakita nyo. Kanina nakita nyo lang is isang faucet, no, tumutulo, and then dinagdagan natin ng pangalawa. Okay? Ngayon, imagine 192 faucets ang nilagay natin sa loob ng isang massive MIMO antenna. Okay? So, sa design ng antenna, we are using this what we so-called wavelength formula. The wavelength formula is lambda is equal to C over F, where C is the speed of light, 3 times 10 to the 8 meter per second, and frequency is measured in hertz. Okay? Ngayon, ang massive MIMO, although we can implement it in any frequency, but it's more practical to use it on a certain frequency. Bakit? Especially for high frequency such as the 3.5 gigahertz. So imagine if we will arrange all those antenna elements into 12 rows. So meron kang 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. And then you have 8 columns. So 1, 2, 3, 4, 5, 6, 7, 8. And then you have 2 cross polarization, positive 45, negative 45. Di ko kayang tanggapin yan. Na gano'n siya. Yan. So, meron kang dalawang polarization. Okay? So, kapag massive MIMO ka, yan ang gagawin mo. No? Yan. Nung nag-seminar kasi ako, nagganyan ako eh. Kumanta yung mga estudyante. Yung nag-sync in sa akin. Now, if you calculate the wavelength of a 3.5 gigahertz, so you will have a wavelength of 8.6 centimeter. Okay? In the antenna design, the antenna spacing element is half of the wavelength. Okay? Half of the wavelength para makuha mo yung mga superposition effect, no? Yung magka-cancel out at mag-gain. Now, the antenna spacing element, if it's lambda over 2, the 8.6 will become 4.3 centimeter. So, ang separation nito is 4.3 centimeter. Okay? Yan, 4.3 centimeter. Ito, dalo ko na lang, 4.3 centimeter. And then this one also is 4.3 centimeter. So, anong impact niyan? What is the impact of that in the, what do you call this? In the physical size of your antenna? Ano mangyari? So, immediately, if you have a 3.5 gigahertz frequency, your antenna will have 60 centimeters in antenna height and 40 centimeters in antenna width, no? Antenna edges. Imagine if you are using 900 megahertz. ang laki ng antena mo. Right? If you're using 450 megahertz, ang laki ng antena mo. At tatanungin tayo, is it possible for you to deploy a massive MIMO using 450 megahertz? Yes, possible. But it's not practical. Because it would be a huge antenna. Para may malaking pinto, no, sa taas ng ano. Napapagalitan ka ng civil works. Sobrang laki nun. Okay? So that is massive MIMO. Okay? I hope you understand the concept of massive MIMO. Why we are using massive MIMO. I have shown you the principle of superposition ng adding and subtracting yung mga in-phase signals, and then the size of the antenna using this kind of frequency for massive MIMO applications. So massive MIMO also have single user and multi-user MIMO. Okay, single user meaning you are transmitting one beam and then it is being shared by multiple users. Okay, so the resources are being shared by multiple users. So you have the PRB physical resource block for user 1 and user 2. But if you're using massive MIMO, since you are transmitting different beams, no? Isang antenna, you can transmit multiple beams. So beam number 1, beam number 2, beam number 3. So if you're transmitting beam number 1 with 100 resource block, essentially you are giving or assigning 100 resource block for user 1, 100 resource block for user 2. Where in case a single user, you are only transmitting 100 physical resource block, and then it will be divided into those users. Kaya ganun kaganda yung massive MIMO. Okay? So isang antenna siya, isang physical antenna siya, but you can transmit multiple beams. Here, isang antenna to, but you can transmit only one beam. Okay? So that is the combination. Ito yung pagkakaiba nila. So this is an 88R antenna, and this is the massive MIMO antenna. Okay? So that is the antenna part. Okay? That is the antenna part. I'll turn off the muna, no? Yung ating chat, no? So that you can focus on the discussion. Next is the frequency. So we have two frequencies in 5G. Actually, in this version, in the newest version, they are introducing FR3. No? But in this topic, let's discuss first the FR1 and FR2. The frequency range 1 and the frequency range 2. Ano ba ang frequency? So, pinag-usapan natin ito sa radio access network that the spectrum is the fundamental asset that provides wireless connectivity. It's an invisible electromagnetic wave aside from the visible light, of course. Is measured in hertz. And then, ito yung ginagamit ng mga operator to have this what we call the wireless telecommunication services. Okay? So, gumagamit tayo ng frequency. So, ginagamit natin frequency dito is nandito. Nandito sa bandang to. Non-ionizing radiation. Huwag niyo na akong tanungin kung ito ay ito ay may effect or wala. Napag-usapan natin ito dati pa. Okay? Now, if you look at the spectrum of 5G, okay, so you have the frequency from 300 megahertz up to 300 gigahertz. Okay? So the applications of EMBB, URLC, MMTC are here. Yeah, so ano yung mga possible applications at saang part ng frequency band pwedeng gamitin? Okay? So just a review, meron tayong formula ng wavelength. Wavelength is equal to C over F, 3 times 10 to the 8 meters. This is speed of light and the frequency. Okay? Now, in terms of frequency, if you compare the frequency of a 5G system compared to other technologies such as LTE, si 5G is marami siyang supported na frequency. Okay? It supports almost full spectrum, no? Ang dami niyang frequency. So, pag tinignan mo siya, meron siyang frequency sa less than 1 gigahertz, nasa 3 to 5 gigahertz, meron siyang 20, meron siya up to 80 gigahertz. Okay? Compared yan sa Compared yan sa iba't ibang bands. So, itong frequency na to, the frequency below 6 gigahertz, specifically from 470 megahertz up to 6 gigahertz, this is what we call the low frequency band for 5G. This is also considered the FR1 or the frequency range 1. Okay? The frequency range 1, this is discussed sa World Radio Conference na ginaganap every 3 to 4 years, na parang Olympics. Okay? So dito pumupunta yung ating mga NTC, they attend this kind of seminars or workshop or conferences para malaman natin ano yung mga frequencies na kailangan gamitin natin at para ma-align tayo sa ibang bansa at ibang region. Okay? We call it the WRC. When we say WRC 15, meaning it's the World Radio Conference of 2015. Okay? Ayan. Asa na tayo? Ayan. So, yung WRC 15, this was held in November 2015 sa Geneva, Switzerland. Ganda, no? Switzerland. Ayan. So, ang ginagawa ng WRC, so their job is to review and if necessary, they revise the radio regulations, no, sa international treaty that governs the use of radio frequency spectrum and yung mga geostationary satellite and non-geostationary satellites. So basically, nag-agree sila anong mga frequency ang gagamitin natin. So nangyari to sa WRC 15. Now, nung 2019 na ginanap sa Egypt, no, October to November 2019, nagkaroon ng panibagong frequency para sa 5G, which is the 24.25 and then 86 gigahertz. So high frequency naman yan. Ito na lang tinatawag nating frequency range 2. Okay? So itong frequency range 2 pumapatak to sa millimeter waves na tinatawag. Ito yung mga high frequencies natin. And if you look at the frequency range na to, ang lalapad ng mga bandwidths dyan. Okay? Malalapad yung bandwidths. So ibig sabihin, malaki yung data capability niya mga yan. Pero merong catch dyan mamaya. Okay? So LTE supports low frequency. Nandito tayo. So pag kinumpare mo siya kay 5G, wala siyang laban, no? Ang dami ng frequency ni 5G. So these are mostly used for coverage and capacity, and this one is for capacity and backhaul. Okay? So although maraming frequency si 5G, in terms of bandwidth then implementation, you can implement different bandwidth per carrier. Si LTE meron lang siyang 6. Meron kang 1.4, may 3, 5, 10, 15, 20 MHz. After 20 MHz, hindi ka na makakapag-deploy ng 25 MHz. Ang gagawin mo, you need to have additional feature, the LTE carrier aggregation. So you will aggregate, no, pagkasamahin mo yung dalawang carrier. Pero kay 5G, hindi mo kailangan mag-carrier aggregation. You can deploy 40 MHz, 60, 80, 100, 200, up to 400 MHz. Isang carrier. Wala pang carrier aggregation yun. Okay? So, ganun ka-ganda si 5G compared kay LTE. Okay? So, this is 4G and this is 5G. Now, if you look at the spectrum band support in 5G networks sa buong mundo, no, as of GSA, no, market snapshot noong September 2024, ang pinakasikat, no, na ngayon is si N78. Yan. So, maraming gumagamit nung tinatawag nating N78. N77 and N78. Marami naka-deploy na N77 and N78. May mga license siya and then they are also evaluating. But essentially, pinakamarami pa rin si N77 and N78. N257, N258, N261 is millimeter waves. Okay? And then yung iba is medyo mababa na. Yan. Sir, hindi kita maintindihan. I cannot understand ano yung sabihin ng N78 and N41 or N1, no? So, kapag tinignan natin yan, ito yun. Yan. So, ito yung N. Okay? Ito yung N values. So, when you say N78, nandito yan. Ito yung N78. Yan. Ito yung N78. N78 is 3.3 megahertz to 4 gigahertz to 4.2 gig. N78 is 3.3, 3.8. N79 is 4.4 and 500. Kasama ang Pilipinas, ang pinaka ginamit din natin is itong N77, N78, and N79. Okay? So, although pwedeng mag-operate si 5G sa iba't ibang frequency, we also need to consider yung user terminal. Remember? So kapag konti ang user terminal, sayang naman. Di-deploy ka ng, for example, gusto ko mag-deploy ng LTE, ng 5G and 261 dito. Kaso wala namang mga users, no? Yung mga telepono ng mga users mo ay nasa N77, N78 lang. So you're just wasting your money, no? Your investment. Wala ka naman palang users. Okay? Ayan. So going to a little technical. So this is what we will see in a 3GPP specification on the definition of the channel bandwidth, transmission bandwidth, maximum transmission bandwidth configuration, and UE channelization or channel bandwidth and subcarrier spacing. Especially we are discussing this 5G radio network design and optimization. Okay? So it's a different topic, no? It's a 5G design. Alam niyo sa 5G, malawak ang discussion ng 5G. Meron design, may optimization, may dimensioning, may capacity, no? May integration. So what we're discussing right now is the general 5G discussion. Okay? So regardless kung ito ay FR1 or FR2, it will just follow itong definition ng bandwidth, resource block, and yung mga guard bands. Okay? Ayan. So kanina napag-usapan natin the importance of frequency selection sa 5G. Okay, so if this is a side view of your site, top view, so if you are using 2100, the top view is ganito ang coverage niya. If you're using a 700, definitely the propagation is farther than the 2100 because of the characteristics ng frequency. No? Mas mabilis ma-attenuate no? yung higher frequencies compared sa low frequency, kaya mas malayo nararating. If you look at this one, so there's a strategy that you will formulate here. So if you want to have some coverage, can use the low frequency, and then to augment or to support the capacity, you need to have a high frequency. Okay? In terms of propagation, talagang mayroon tayong problema for the high frequency because it cannot, part of this characteristic cannot completely penetrate between walls and mga barriers compared sa low frequency na tumatagos talaga siya. Okay? Kaya sa mga IoT devices, kung gusto natin i-cover using a macro, we are using a low frequency band so that yung mga IoT devices natin is ma-connect siya sa network. Okay? Yan. Okay, so if you compare this also sa isang simulation, yung 28 gigahertz is very prone sa different clutters, particularly sa mga puno. For example, ito yung simulation na walang puno using a 28 gigahertz. If you put buildings and trees, this would be the effect. No? Ang laki ng impact sa iyong propagation. Okay, kapag gumamit ka ng 28 gigahertz. So there was a news last time, South Korea, binalik niya yung 28 gigahertz no, dun sa pinaka parang regulatory nila kasi ang liit masyado ng coverage. No? Hindi niya ma-capitalize no, yung investment niya dun sa frequency na binili niya na pagkamahal-mahal. Okay? Ayan. So in terms of frequency, talagang mas ano siya, no? So meron siyang different pros and cons. So for 28 gigahertz, so you can get up to 5 gigabit per second. So that we use this for hotspot capacity and fixed wireless. Okay? For 3.5, which is optimal for urban capacity with massive MIMO, we can get up to 2 gigabit per second. And for wide area and deep indoor coverage, we use the 700, although may decent speed naman siya up to 200 Mbps. Okay, so this is how you can strategize deploying 5G. So when you deploy 5G, for example, meron tatlong bands. Not necessarily tatlong cell site yan. So sa isang cell site, meron kang tatlong frequencies. Tatlong radio. Radio 1, radio 2, radio 3. So yung radio 1, meron kang 700, pang coverage yun. Radio 2, may 3.5 ka for capacity. And then for hotspot, kung talagang nasa densely populated area yan, so you can still use the millimeter wave. Okay? Ayan. So bigyan ko na kayo ng strategy, sample network spectrum strategy. So this is the rural, dense urban, urban, and suburban. Rural, meaning ito yung mga probinsya natin. Like dito sa Laguna, sa Laguna yun. Layo-layo yung mga bahay. Okay? So, mga 500 meters bago mo makita yung next kapitbahay. Ganun. Rural area. Dense urban, like BGC, Makati, and Ortigas. Urban areas like Muntinlupa, Las Piñas, Parañaque. No? Suburban, yung mga villages natin. Yan. Ito yung mga different classifications no, ng areas. So what you can do is you can deploy FDD, LTE or 5G 900 or 700, depende sa frequency available sa operator. And then if you have FDD 1.8, you can use this, 2.6, 3.5, and NR for future band. So this is the logical or practical implementation of 5G frequencies. Kaya minsan makikita mo, sir, paano po ba yung frequency? So you are considering, of course, yung propagation and yung capacity. Usually, yung mga high frequency, matataas ang capacity niyan dahil malalapad. Okay? And then yung mga low frequency naman, talagang malalayo nararating niyan, pero maliit yung capacity niyan. So you need to mix and match depende dun sa pangangailangan ng iyong target area. Okay? Yan, no? So, I want to go deeper sa frequency. Sige, try natin. So, sa 5G, we also have what we call the numerology. Okay? So, numerology. So, numerology, it's a technical term, pero essentially, ang ibig sabihin lang ito is subcarrier spacing. Gaano kalapad yung isang subcarrier. Okay? So, for example, if you are using a 15 kilohertz subcarrier, we call it the numerology 0. If you are using a 30 kilohertz, you're using numerology 1. And then numerology 3, and so forth. Si LTE is gumagamit ng katumbas ng numerology 0 or the 15 kilohertz subcarrier spacing. And then when you look at the frame structure in 5G, okay, sorry, as much as possible, I don't want to talk too technical. Pero let's just complete this. So meron tayong different numerology. So ang ginawa kasi ang ginawa kay LTE kasi, previously si GSM, you can only transmit 200 kilohertz in one carrier. 200 kilohertz. And then when 3G came, yung 200 kilohertz na yan became 5 megahertz. It's a fixed 5 megahertz. Fixed 200 kilohertz. Now, when they introduce LTE, they want flexibility. So the flexibility has achieved using an OFDM technology where you can adjust yung bandwidth. So that in the LTE, you have 1.4, 3, 5, 10, 15, and 20 megahertz. So not anymore fixed sa 200 kilohertz, not anymore fixed sa 5 megahertz. Now, itong LTE na to, yung 1.4, 3, 5, 10, meron siyang maliliit na subcarrier sa loob, which is 15 kilohertz ang bawat isa. Now, nung dumating si 5G, they also want this subcarrier to be more flexible than LTE. That's why from the 15 kilohertz, nagkaroon pa tayo ng ibang variations. 15, 30, 60, 120, and 240. Because we have different use cases. Meron tayong EMBB, URLLC, and then yung MMTC kasi it's either pwede naman kahit ano. Pero itong dalawan to. Okay? Kaya nagkaroon tayo tinatawag na different numerologies. Yan. So ang numerology is yung subcarrier spacing lang, 15 kilohertz, 30, 60, and 120. And then meron tayong mga subframe na mayroong 14 slots sa isang subframe. You will see, ito habang lumalaki yung iyong numerology, dumadami yung iyong mga symbols in one subframe, no? Kasi madami siyang symbols, no, na nakukuha dahil mas maliit yung kanyang time. Yan. Ito yung ating numerology. Ayan. So, yun yung ating frequency, no? Ayan. So, marami talagang pag-usapan sa frequency kasi pagdating sa air interface, medyo merong isa pang course for 5G air interface para mapag-usapan natin. Okay, next is the transmission mode. Yan. So 5G can also use TDD and FDD. Bakit? Because it connotes with the type of frequency that you will use. If it's FR1, you can use FDD. If FR2, you will use TDD. Right? So what's the difference between FDD and TDD? No? So FDD means of basics muna tayo ulit. So meron kang cell site, okay? Meron kang cell site and then meron kang user terminal. So the channel or the direction from the base station or the G node B going down to user terminal, we call it downlink. Downlink. And then yung pagbato mo naman mula user terminal going to base station or the G node B is what we call the uplink. Okay? Downlink and uplink. The question is, if you are using different frequency for downlink and uplink, we call it frequency division duplex. Okay? Frequency division. We divide the frequency for those two directions. Now, if those directions, uplink and downlink, are using only one frequency, we call it TDD or time division duplex. Okay? So separated lang siya by time. So meron kayong maririnig na supplemental downlink and then meron kayong maririnig na supplemental uplink. So this is additional feature ng 5G. So for example, you want to capitalize yung link budget for the uplink, so you can use different frequency for the uplink. Yeah. So kung gusto mo ma-capitalize yun. Or if you want additional capacity for downlink or uplink, you can use supplemental. But definitely, it's TDD and FDD. Okay? Next, malapit na tayo matapos. Architecture. Yan. So, si architecture, we have two major architectures for 5G. We have the non-standalone or the NSA and the stand-alone. What are the differences ng standalone and non-standalone? Okay? So, before that, naalala niyo yung discussion natin with SDN, software-defined networking, where you are separating the control plane and the user plane. No? So in 5G, we're applying that also. We call it the CUPS. No? Control and user plane separation. So we separate the control plane and the user plane. So that's why when you have the access or grant, so that's coming from the control plane. So the user plane is the data. No? Paladaanin ka na yung data mo. So para kang meron kang truck na you have a payload, but before you enter the gate or you enter the subdivision, you need to have approval from the security guard. And then the security guard will look at the different requirements. Are you allowed to enter in this subdivision? How much paid data load payload can you carry inside the subdivision? So that is what the control plane do. And then the user plane, once you have the approval from the user plane, so the data will flow on the network. So ganun yung ginagawa niya. Kaya dito, meron tayong NGU, okay, next generation user plane and control plane. So you will see these two kind of lines, no? The dotted line and the solid line. So let's start with the NSA. So non-standalone mode. So the non-standalone mode allow a smooth and relatively simple evolution towards a complete end-to-end 5G system. Yan. So non-standalone mode yan. So the non-standalone mode architecture allows the reuse of existing LTE base station and existing 4G core networks. Yan. So in general, a software upgrade, syempre. You need to have a software upgrade to allow the interworking with the set of NR base station. Okay? So, essentially, ang nangyayari talaga dyan is, meron ka lang LTE. You only have LTE network. Okay? You only have LTE network. You have the EPC, the Evolved Packet Core, connected to the E node B, the Evolved node B, the LTE node B. Now, what you will do, you will just add this baseband unit and the active antenna unit. And then you will have a connection directly to the EPC, and then you will have a connection of X2 to the E node B. And then you will have the what we so-called ENDC, the E-UTRA NR dual connectivity. So what is it? So that means your system or your phone is connected to LTE and 5G simultaneously. You look at your phone. If you see a 5G signal here, and then you do a signal test, so you will not see that your phone is connected to LTE and 5G at the same time. If you use a drive test tool like this, you will see that there is a parameter showing how much throughput, how much data is transmitted in the NR, and then how much data is transmitted in the LTE. Ngayon, wala pa yun. Yan. So there is a data, no? Yan. So nag-share sila. So meaning you are connected to LTE, to 5G, and LTE simultaneously. So we call that ENDC. Okay? We call that ENDC, the EU-TRAN NR dual connectivity. So that is the fastest way to implement a 5G network sa iyong LTE system na ginawa natin sa Pilipinas at sa ibang bansa. NSA. Okay? So it supports EMBB, reuse of current EPC and LTE as an anchor. So we call it the anchor, and the dual connection of user data. Okay? So siyempre, yung dual connectivity, that's the basic explanation. So there are features pa rin na binabago natin, but that is changing from vendor to vendor. Okay? Now we have the option 2. Yan, option 2. Option 2 is what we call the SA or the standalone. So sa standalone, you need a dedicated 5G core network. So you need to have a dedicated 5G core network, and then you have a G node B. Definitely, you need to directly connect your G node B into a 5G core network. So we call it standalone. May sarili siyang bahay. Hindi siya nakikitira. Cannot stand alone. No? So ganun yun, non-standalone. No? You don't have your own house. You live in your parents' house. So you cannot stand alone. No? Stand alone. But if you're standalone, you have your own core network. So that you can remember. Okay? So it supports EMBB, URLLC, MMTC, and end-to-end network slicing. Okay? So ito yung kagandahan. So this is the holy grail. So this is the one that we want to achieve. Because if you are standalone, alam mo naman, if you are standalone, you can do whatever you want. You can go home anywhere you want. No? Anytime you want, right? You can go home anytime you want. You can eat whatever you want. You can invite anyone you want. So a standalone supports the end-to-end. Yeah. But if you are non-standalone, no, what happens is that if the UE must first connect to LTE, and the LTE is the control or the master node B that will ask the G node B to become a secondary node. So hindi ka makakakonekta direkta kay 5G agad. Kinakailangan mo na magpaalam sa may-ari ng bahay. Okay? You need to get permission first to the owner of the house before you add a secondary node. So ayun ang kagandahan kay option 2. Okay? So it requires good coverage. Of course, option 2, you need to have a good coverage. I hope you understand the difference. No? I'm making it simple to understand. I don't want to go on the detail of the technical details unless nasa loob kayo ng academy, ni Asia Open Academy. Okay? That's the time that we will discuss about the protocols and the different call flow. Okay? So let's see, no? Deployment architecture options. We have the option 1. Option 1 is actually not a 5G, but they call it option 1. It's an LTE actually. EPC and eNode B. Kasi magtataka kayo, bakit merong option 3 at may option 2? Asan yung ibang option, sir? So, nandito siya. Option 1 is the LTE setup. Okay? So, this also considered as standalone, pero this is an LTE system. Okay? Technically, it's not a 5G deployment option. And then you have the option 2, where you have a 5G core and G node B. Okay? And then you have the option 3. Option 3 essentially is an LTE na kinonektahan ng secondary node na G node B. It's option 3. Right? Now there is option 4. Option 4 is a 5G option 2 na nilagyan mo ng LTE. So ganun ka-flexible si 5G architecture. You can implement 5G either option 3, option 4, or option 2. Okay? So the term we use for the LTE connected to a 5G core network is the next generation E node B. Okay? Next generation E node B. And then you also have 5G option 5, where you have a 5G core. I don't know why you are using an NG E node B, no? Yeah. Probably in some cases, no? Probably in some cases. Yeah. But the 3GPP has set this deployment option. It's up to you if you want to use or if you find a use case applicable for this kind of architecture option. And then you have the option 7. Actually, merong option 6. Option 6 is EPC, and then you have a 5G node. No? Pero bihira yung application. And then you have the option 7. Option 7 is 5G core, and then you have the E node B. It's a 5. It's like something like this, option 5, and then you have a secondary. Okay, so these are the different options of architecture, so you can deploy. Now, if you reach this kind of interview in your technical interview or topic, it's good, no? Kasi you know the differences of option 1, option 2, 3, 4, 5, and 7. Meaning, malaking offer dyan. Okay. All right. So now let's see some asa na tayo. Lapit na tayo matapos. Voice services. Yeah. So voice services. Of course, katulad ng LTE, we also have voice services for 5G. Nung na-launch yung LTE, even though it's all packet, no? All packet services or IP services. Marami kasabi, paano tayo tatawag? Wala na tayong CS, no? Wala na tayong circuit switch. When you say circuit switch, kasi you have a dedicated channel. So, remember yung plain old telephone system. Kapag inangat mo yung telepono, when you answer a call, magkakaroon ka ng closed circuit eh. Pag tinignan mo yan, mula dun sa yung terminal papunta sa central office, you will have a closed circuit. And then nobody can use it except you because it's dedicated. Okay, kaya tinawag niya na circuit switch, no? Voice. Ginamit din natin 'yon sa GSM, yung system na 'yon, and sa 3G. But in 5G, in LTE, we cannot do that anymore because it's all packet based call. So we have a packet call na. So your call is now translated into packets, no? So parang ano yan, parang umorder ka ng Grab, tas marami kang in-order na foods. And then those Grab will eventually come at the different locations, but essentially it will arrive in one certain location, no? Parang ganoon yung packet data. Na hindi siya talaga nagpa-deliver ka lang, isang truck lang siya and then isa lang yung route. So yung packet data, you can have a different routes. Okay? And then timings ng pag-attend. So the voice services ginawa sa LTE is the circuit switch fallback, the CSFB. So what will happen, you can try it also in your phone. If you have LTE signal right now, and then if you are not connected to Wi-Fi or VoLTE or voice over LTE, once you initiate a call, tumawag kayo sa crush nyo, tawagan nyo yung crush nyo. When you dial the number of your crush, essentially, you will see LTE will become either 2G or 3G. So that means your call has come from LTE and then goes to 2G para magkaroon ka ng circuit switch. So we call it the circuit switch fallback or the CS fallback. The good part is sinagot ni Crush yung tawag. Sabi ni Crush, bakit? Bakit yung tumatawag? I'm just trying the circuit switch. Sorry, I'm just trying the circuit switch fallback. Bye. Yun lang. So that's a circuit switch fallback. Okay? Now, if there's a volte, so it will just reflect on your signal icon volte. Yan. Or vo Wi-Fi. Yan. So sa 5G, meron din tayong voice services. So remember yung option 3, option 2, option 4, option 7, option 5. So we have different options, right? So we can have voice or over-the-top VoIP. So example, luma-luma na example ko. 20 ano pa kasi ito. Skype. No, you can use Skype or Viber, Messenger, WhatsApp. What else? What else? Ano yung mga sikat na apps na pwedeng yung tumawag? Forgot na yung mga na yun. Ayan, basta Viber, mga over-the-top. Yan. Over-the-top VoIP. Okay, kaya minsan makikita nyo, mayroong mga bansa, may mga countries that they don't allow over-the-top VoIP because they want to support also their operators not to kill the CS fallback. Diba? Kasi minsan ngayon, for example, you are already using Viber for calls or Messenger. You're not already using voice call because mahal. Diba? So instead of calling them using voice call, you use Viber because meron pang data, mas mura. So what happens is that bumababa yung usage mo sa sa CS fallback, sa CS, no, sa circuit switch. So some countries they support yung voice services. Okay? So kapag ka option 3 you will have CS fallback. Okay? For option 2 and option 4 we call it the EPS fallback. Okay? For option 2 we also have the RAT fallback. The Volte, you can also implement Volte. If you are using 5G core like this, we have the VoNR. Okay, voice over NR. This one is voice over LTE because you have a LTE core. Okay. Now, merong isang pausong term, VoE LTE because the master node is LTE. So essentially, it's VoE LTE. It's like a Volte. No? Pero essentially, meron ka pa rin voice call sa 5G. Either over the top, EPS fallback or RAT fallback or VoNR. Okay, hindi mawawala yan. Makakatawag pa rin tayo. Don't worry. Okay? Ayan. Okay, so meron tayong voice services and then we have the location. Okay, so there are 5G that are located on the surface of the Earth and there are 5G that are located spaceborne, no? Lumilipad. We call it the terrestrial and the non-terrestrial network. Okay, ano yung, alam niyo na yung terrestrial, terrestrial, pinag-usapan natin. So anything that is buried on ground, yan, terrestrial yan. But the non-terrestrial, we call it the non-terrestrial networks, NTN. You will hear it especially nung lumabas yung release 16, 17, and 18. Yan. So the non-terrestrial network is a network based on spaceborne spacecraft or an aerial platform for radio transmission. Anything na lumilipad. So kasama dito yung mga drone applications. Yan. Okay? Mga high altitude platforms. Okay? Ito yung mga low altitude platforms yan. And of course, yung mga satellite natin. So kasama yung mga LEO, low Earth orbit, medium Earth orbit, and HEO, no? And then yung GEO natin. Okay? So alam niyo na yung isa sa mga pinakasikat, di ba? Pinakasikat isa is si Starlink. Yan. NTN. So we use NDN to extend coverage to places without terrestrial coverage. Katulad ng Starlink, no? Kakaroon tayo niyan. Pero ngayon kasi si Starlink is more on ano pa lang eh. More on Wi-Fi pa lang eh, di ba? So you will have a dishi. So si dishi is connected dun sa satellite niya, sa LEO constellation. And then from the dishi, you will translate it to Wi-Fi. Di ba? So you have a Wi-Fi, makakonect ka. Pero in some places, you can have what we are expecting is direct to the phone. So meaning you have a phone, no need for dishi. You can connect directly to the satellite. Okay, so that is what we are expecting in the future, especially here in the Philippines. Okay, so mission support, supporting mission critical services and providing 5G reliability and resilience. Okay, ayan. So this is just an additional illustration. What are the differences of a non-terrestrial network? Okay, so you have your UAV, unmanned aerial vehicle, air-to-ground, high altitude platform or HIBs, and satellite network. Okay. Okay. So the non-terrestrial network is used to extend coverage, mission critical services, and providing reliability and resilience para sa ultra reliable and low latency. Yan. Okay. So that is for the terrestrial and non-terrestrial network. Now, puntahan naman natin in terms of privacy. So you have the public network and the non-public network or NPN, the 5G private network. So the public network, ginagamit na natin to. So yung network natin, as long as na-access ng public, bumili ka ng SIM card, you can access the network. So that is part of the public network. But if you confine the network that a few selected people or selected configuration of a SIM cards or user terminals can access the network, we call it the non-public network. Napakasimple ng mga terminology. Did you notice? Kapag ang cell site is hindi nakabaon sa lupa at hindi siya terrestrial, we call it non-terrestrial network, right? Did you notice that? Kapag non-public, pag lumabas to sa PRC board exam, what do you call a public that is not accessible to the public, no? Not available to the public? A, non-public network, di ba? Ang dali na, no? Yung 5G core network. What do you call the 5G core network? 5G CN, no? 5G core network. Ang dali na nga. Dali na mga terms na. Anyway, so going back to the privacy, public network and the non-public network. So let's focus on the non-public network. So the non-public network is also known as the private network. Yan. So lumabas siya noong release 16, the non-public network. Okay? So meron tayong tinatawag na mga standalone. Yan, non-public network. NPN. Now, NPN. Yan. So NPN is operated by an NPN operator, not relying on MNO. Ito nangyayari to sa ibang bansa. Why? Because sa ibang bansa, they have, for example, in the US, they have the CBRS band. You don't need a franchise to get a frequency and then and then deploy your own network. Dito sa atin kasi, you need a franchise, no? You need to own the frequency. Unless Wi-Fi yan, na free frequency. Pero if you're using yung mga dedicated channels or frequencies natin, like 400, 900, 850, 2100, you need the franchise, like the MNO. And then most of the frequencies right now are already owned by MNOs. Okay, so kung meron magdi-deploy ng private network dito, nasa MNO pa rin, di ba? Kasi essentially, nasa kanila yung frequencies. Yan. Pero sa ibang bansa, they can do this. Okay? Hopefully, magawa din natin sa Pilipinas. Hopefully, if we have this frequency na pwede nating ibigay for, okay, gusto mo mag-deploy dyan? Deploy ka dito, di ba? For example, merong isang village na hindi mabigyan ng coverage dahil bagsak yung business case. But there is somebody that would like to take the risk or invest, no? But ang problema niya, wala siyang frequency. Pero kung meron tayong separate frequency that will allow system entity to deploy a private network, we can use it. No? So it's an opportunity for innovation here in the Philippines. So what I'm looking at is that, for example, no, instead of just a laboratory, that we will implement here in the Philippines, why not an innovation zone, no? Like the one that they are implementing in the US. Innovation zone is that something like, for example, sa isang part ng Bulacan or Clark, which you can have test sites, magbibuild ka ng cell sites, and then you have a separate frequency for that, and then you can do any experiment, research, no, or academic purposes na makakapag-study, makakapag-trial, makakapag-experiment yung mga estudyante or mga researchers natin for innovation purposes. Which talaga makakaikot sila, makakapag-drive test sila, right? Kasi ngayon nangyayari yan for operators, but they own the frequency. They are doing it for their own, no? For their own study. But for universities, researchers, government agencies, we need this kind of innovation zone where we could invite, no, yung mga researchers, mga academicians, yan. Naisip ko lang. Anyway, and this is a non-standalone NPN, and then you have this public network integrated NPN. Yeah. So this one is deployed with MNO support. Yeah. So dedicated spectrum, yeah, closed access group, yeah. So marami, no. So it could be a collaborative approach. Eh. So you could have your own spectrum, you could have your own SIM cards, security, roaming, and then cloud computing or edge computing you have. So you can have a standalone NPN. So bahala ka, meron ako sarili kong network. But if you want to collaborate with MNOs or mobile network operators, you can also use that. Especially if the MNO owns the spectrum. Okay? So you can also do that. And then the MNO will be the integrator, and the security will be responsibility of the MNO, the end-to-end security as well. But there is yung core network mo, sarili mo. No? Ikaw ang mahalang, hindi na access ng MNO yung data. Yan. So pwedeng gawin yan. So maraming options to deploy. So we could have standalone, no? Enterprise. So you have your own core network. You have your own core network. And then you have your own network. So private yan. It could be hosted. So pwedeng si MNO yung magbe-build, and then they will issue you a SIM card, but you will have a dedicated access dun sa network. Yeah. So pwedeng baguhin lang yung configuration ng SIM cards mo. Yeah. So giving you some slice. Yeah. Run sharing. So meaning like a run sharing, no? Merong frequency si MNO, and then you can use that frequency, but you have a different SIM card, and then you have a different core network. So that's run sharing. So we can use that also, especially yung mga tinitignan na run sharing applications. So meron tayong dalawang klaseng run sharing. Una is the MOC-N, the multi-operator core network. Okay, MOC-N. So meaning only one frequency yan, tapos only one radio, one baseband unit, pero naghahati sa core. Yan. Yung isa naman is MORAN. Medyo na yung term, MORAN. MORAN is multi-operator radio access network. So meaning, in one radio, you can use frequency 1 of the operator and then frequency 2 of one operator. Physically, isang equipment siya. But you're using different frequencies. We call it the MORAN. Okay? So that is run sharing. And then you can have this what we call the MNO slice. Yeah, yung network slicing. Okay? Ayan. So ito yung mga private network. Pwede yan. So 5G. So if you want to deploy 5G as a private network, I think you can just request a test frequency from the NTC. Mabibigyan nila kayo niyan, yung test frequency, to do your own private network. And then pag pumunta kayo sa US, tignan yung mga different equipment. Marami nagbebenta rin ng mga private network na equipment. And then dito sa Pilipinas, I believe meron na rin eh. Just do the research, no. kung meron na silang mga equipment pati software for 5G. But in terms of Open RAN, yeah, marami rin, no? Marami ring deployment ng private network. Especially for example sa Singapore, yung isang university ron, Singapore University for Technology and Design, they deployed a private network 5G sa loob ng university, inside the university. Imagine, meron silang network ng 5G sa loob ng university. And that is not powered by any operator. Sila lang gumawa nun. And that is an open RAN. Meaning they are using COTS of server, commercial off-the-shelf server, mga Dell servers natin. And then nakipag-partner lang sila sa isang vendor ng open RAN. And then they integrate it. No? So they have their, and then yung frequency nila is they have a support from their government in terms of the frequency. Yeah. So kaya na-implement nila. Kasi kung wala silang frequency, they could not implement that. And what's good about having a private network in a university, they can do research about drone applications. Meron silang drone cage. 'Di ba kapag meron tayong university, meron tayong university. Usually ang mga university enclosed eh. Ganyan siya, 'di ba? Tapos meron siyang parang park sa gitna. Ayan. Tapos dito yung mga building. Kapalipat na ganyan. Nilagyan nila to ng net. May net yan. May net. Net. Para yung drone hindi lumabas. So dito sila nagka-trial ng drone applications. So they are looking at the different applications ng drones, especially for critical services, emergency services, or delivery services, anything na pwede nilang paggamitan sa drone. No? And then meron silang yung mga rover na powered by 5G. So gumagawa lang sila ng mga 5G circuits, and then yung SIM card sila is open source din. Okay? So doon kami nag-training nakaraang August sa SUTD. Okay, so maganda yung school nila. Talagang makita mo yung innovation sa area. And they are fully supported by the government and by different operators. And hopefully dapat sana mangyari din dito sa atin. Okay? So yeah, that's it, no? Yun yung ating napag-usapan about 5G, no? So just let's have a recap, no? Pinag-usapan natin ngayon yung a need, no, for connectivity. Yan. So pinag-usapan natin ano yung mga challenges pag walang connectivity, and then pinag-usapan natin yung mga components ng wireless telecommunication system from user terminal, RAN to core network, and then paano sila nag-evolve, no? So from 1G, 2G, 3G, 4G, and 5G. And then we focus our attention sa 5G. Define natin ano yung 5G technology. Okay? And then pinag-usapan natin ano yung mga use cases ng 5G, EMBB, URLLC, and ultra-reliable latency. And then tinignan natin no, ano yung status ng 5G sa iba't ibang bansa. What are the different status of deployment and commercial networks in different parts of the world? Saan sila naka-locate and what are the different opportunities waiting for us? And how we do initial deployment of 5G. And of course, pinag-usapan natin what are the typical deployment type or solution that we can see in terms of implementation. And we check no ano yung mga different configurations, systems, and factors, no, like antenna system, how to select the frequency, what are the transmission mode, the architecture, the voice services, the location, and the privacy. Yeah.